Today I'll be explaining about the binary search algorithm. So binary search is a technique which is used to find the index of an element in a sorted array. So the array needs to be sorted. This is a very important point to be noted, that the array needs to be sorted to use binary search technique, otherwise the technique fails. So in a sorted array, let's say we need to find the element 16, which is at the 6th place in the array. In a normal iterative way, we would require 6 iterations to find the index of the element, or to find if the element is present in the index. Or in the worst case, if the target is present at the last position of the array, it's going to take you the whole length of the array to find the index, or if the element is present at the position. So to simplify that, in sorted arrays we use the binary search technique. So the algorithm is something like, we define a left pointer and a right pointer. The left pointer is initialized to 0th index, so this is going to be the left pointer, and the right pointer is going to be initialized to the last index, which is the length of the array minus 1. So here is the left is initialized to 0 and the right is initialized to 7. So 7 is the index of the last element. So the algorithm goes like, well, left is less than or equal to right, so that left doesn't cross right. They don't have to cross each other. We run the algorithm till then. Left can be equal to right, but left should not be greater than right. So while this condition satisfies, we compute the mid, which is the left index plus right index divided by 2. We compute that, and we check for 3 conditions. We check if the element present at the mid index is equal to our target. If then that's the best case, then we return the mid, the mid, which is the index of the element of our target. Else, if we see that if the target is greater than the element present at the mid, then we change left pointer as mid plus 1. Why do we do that? Because let's first finish the algorithm and then see an example. So if the target is greater than the element present at the mid, we do left is equal to mid plus 1, and else if the target is less than the element at the mid, we do right is equal to mid minus 1. So we'll see why we do those things. So here the left and right are initialized to 0 and 7. So at first our mid will be 0 plus 7 by 2, which is 3. So 8 will be our mid. So 8, we run the algorithm again. We find if 8 is equal to target. No, it is not equal to target. We find if 8 is less than target. Yes, our target is 16. 8 is the element at the mid. So the element at the mid is less than target. So we move the left pointer to the next element after the mid index. So we do this because we know that all the elements present before 8 are going to be less than 8, and after 8 are going to be greater than 8. And since we know that the target is greater than 8, it is going to be in the right half of the array. So we discard this whole left half. So that's why we increment the L to the next element of mid. And because we also know why we are not moving it to mid is that because we also check that if the mid is the target, so we discard the mid index also. So we move all of these left part and we move the left index to 12 here, so which is at the 4th index. And now our mid will be 4 plus 7 by 2, which is 5. 5 is 16. So we run the algorithm again and we check if array of mid is equal to target. In this case, yes, it is equal to target, which is 16. So we return the index of the target, which is 5. So 5 will be our answer. So this is the binary search algorithm, and we found that it only took us three iterations. First one when the left and right pointers were at 0 and 7. Second it was at 4 and 7, and third it was at 5 and 7. After this three iterations, we were able to find the position of the element 16. In a normal non-binary search technique, in the general way, it would have taken 5 iterations to find the index of element 16. And when we generalize this, when we are iterating through n elements, after the first comparison, it reduces to n by 2, and after second comparison, it reduces to n by 4. That's the number of elements that we are looking at. After the third comparison, it reduces to n by 8. So by observing this, we can say that the time complexity of the algorithm is log of n. So let's say that if 1000 elements are present in an array, normally it would take 1000 iterations in the worst case to find the index of the element. Here it takes only approximately 10 times to find the index of any element. So this is how binary search algorithm makes our life easier when the array is sorted. So thank you.